Alright class, so I give you 3 take-home problems. Let's do those and then hopefully you get this polarity and loose structures down. This would be our last lecture for this chapter. So OF2, the same as before, number of valence electron would be 20 valence electron. Hopefully you're getting this down. It's 20 valence electron because oxygen has 6 valence electron and each fluorine have 7 valence electron. 7 times 2, 14 plus 6 is 20. So 20 electrons are involved in bonding. 20 electrons are involved in bonding because valence electrons are involved in bonding. Then oxygen goes in the middle. Oxygen goes in the middle. And then you're going to put the fluorine around it. Doesn't matter how you put it around it. Just put it around it. At the end, you can fix it once you figure out the geometry. And we know that in each covalent bond is sharing 2 electrons. So together, right now, I put down 1, 2, 3, 4. So 20 minus 4 is 16. Use the calculator on the exam. You'll be surprised on the exam. When you're stressed out, you can get easy math wrong. I do it all the time. So I have 16 electrons left. I have to make sure my surrounding atoms are happy. Fluorine is not happy. It has 2. It needs 6 more. It needs 6 more to have 8 and have the complete octet. Here, the fluorine has 2. It needs 6 more again that to have 8 and have a complete octet. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I put 12 electrons down and I completed the octet for my surrounding atom. So 16 minus 12 would be 4 electrons left. Now, what am I going to do with the 4 electrons left? Okay, my surrounding atoms are happy. Then I go to my center atom. I have 4 electrons left, so I'm going to put it on my center atom. And we said, when on your center atom, on the middle guy, when you put electrons that are not involved in bonding, right? These are not involved in the bonding. What I wanted us to do, to put a circle around it. So I have 2 lone pairs. It has to be pairs, so it has to be 2 is lone pair, 2 is lone pair. So far, so good. Okay. Nice job so far. Now, the other thing I asked you to do, draw a new structure, figure out the geometry. Take out the geometry handout for me. Here is it for me. Okay. Now, again, we said whisper geometry. The geometry are based on they putting the atom as far away as they can from each other. And again, keep in mind, this is 2D. You have to think 3D a little bit. All right, so what is the geometry? Oxygen is in the middle. Oxygen has 2 bonds and has 2 lone pairs. Hopefully you're shouting that. Bent. Yeah, bent is my geometry. I agree. It's a bent geometry. So far, so good. Okay. Also, one thing I forgot to mention, once we put the lone pair on the center atom, 1, 2, 3, 4, 5, 6, 7, 8, the center atom was happy. So this one has 8, is happy. This one is 8, is happy. This one is 8, is happy. And there was no electrons left. Yeah, sorry about that. I forgot about to do that. Okay, so bent is a geometry. Perfect. Now, the last thing I ask you, is this polar or is this non-polar? Is this polar or non-polar? This is polar. This is polar. Now, why is it polar? Here's why. So, you know that fluorine is more electronegative, right? So, what that means is that the fluorines are pulling the electrons toward themselves, right? So, the fluorine are pulling electrons toward themselves. And the geometry matters. So the fluorine are pulling electrons toward themselves. Now, it's not linear. If it was linear, sure, they would cancel each other out because this goes this way, this goes the other way. But this one is bent, right? So they're pulling the electrons down this way. What that means is I have more electrons on one side of the molecule and less electrons on the other side of the molecule. And again, we'll go back to the last lecture. Polarity is when electrons are not distributed evenly. And in this case, electrons are not distributed evenly, because one side, this side has a lot more electron and the other side doesn't, because fluorine are pulling the electrons that way. Now, the reason that I added this small little lecture is because sometimes we have a hard time visualizing, okay, this is polar or non-polar. I want to give you a shortcut, okay? There's a shortcut. And what I want you to do, I want you to circle bent geometry, pyramidal, and the other bent. So the geometries that I just circle, those are polar geometries. So when you have a lone pair, what happens is the lone pair pushes the molecule down. So you have a lone pair, instead of bent, it pushes the molecule down, and then now one side has more electron, so those are the polar geometry. So that's kind of a shortcut. So bent is here, is polar. But I wanted you to really understand it. That's what we had last lecture. I didn't want you to just memorize it. So those are the polar geometry. Now there was one more hint though. But if you have, and we talked about it last time, if you have more than two types of atoms, then it's going to be polar no matter what the geometry is. So if you have more than two types of atoms, we talked about it. There's no way you can have two best friends and you can all cancel each other out. Then you have more than two types, when you have three atoms, there's no way they can cancel each other out. But when you have two atoms, you can say these are geometries are polar. Okay, beautiful. Let's go next one. HCN. So hydrogen has 1 valence electron, carbon has 4, and nitrogen has 5. So together they would have 10 valence electron. We said hydrogen could never go in the middle, so carbon is going to go in the middle because hydrogen makes only one bond. It could never go in the middle. Carbon goes in the middle. I draw a bond between the center atom and the surrounding atom. Now I've already put down 10 electrons are involved. So I've already put down 4 electrons, okay? 1, 2, 3, 4. 10 minus 4 is 6 electrons left, okay? Now, is hydrogen happy? Remember, hydrogen is an exception. Hydrogen is happy with 2, so hydrogen is happy. Is nitrogen happy? No, it has 2. It needs 6 more. It needs 6 more to have 8 and to be happy. So I made sure my surrounding atoms are happy. Hydrogen happy, nitrogen happy. Okay. Is carbon happy? Carbon is not happy. 1, 2, 3, 4. 1, 2, 3, 4. Carbon has 4. So carbon has 4 electrons. How many more does it need? This is what happens when I make video too early in the morning. I'm not up yet. So carbon has 4 electrons. How many more does it need? Needs what? Needs 4 more electrons. You guys are following me so far? Okay. So carbon has 4 electrons. It needs 4 more electrons. Now, if you need 4 more electrons, how many bond is that? Because remember, each bond has how many electrons? Each bond has 2 electrons. So carbon needs 4 more electrons. Each bond is 2 electrons. So carbon is how many bonds? So carbon is going to need 2 more bonds. I'm going to go over this one to make sure you're really understanding this. So carbon has 1, 2, 3, 4 electrons. It needs 4 more electrons to be 8. Good? Okay. It needs 4 more electrons to be 8. Which means it needs 2 more bonds. Because each bond is 2 electrons. And it needs 4 electrons. So it needs 2 more bonds to have 8. Okay. Now I can't really take it from the hydrogen. My only option is nitrogen. I need to make 1 bond. I need to make 2 bonds. Because it needs 2 more bonds. So it'll be carbon. attached to hydrogen, and let me see, triple bond to nitrogen. So let me actually draw all these ones so you can see. Yeah, okay. Is carbon happy? Let's actually go over all of them. Hydrogen is happy, 1, 2. Nitrogen, 1, 2, 3, 4, 5, 6, 7, 8. Happy. Carbon, 1, 2, 3, 4, 5, 6, 7, 8. Yes, they're all happy. That was a big one. Okay, what is it? Geometry? Again, we said the double bond and triple bond doesn't make a huge difference on geometry, so it would be linear. The geometry would be linear. This is a linear geometry, right? Okay, the double bond and the triple bond does not make an effect. They don't change the shape, okay? So there's things over here, no lone pair on the center atom, so you would be linear. Now, is it polar or non-polar? Hopefully, okay, yes. If you look at over this, linear is a non-polar geometry. These ones are the polar geometry. Linear is a non-polar geometry. But here's the thing. Every time you have more than 2 types of atoms, it's going to be polar no matter what, because 3 atoms cannot cancel each other out. Is that the case here? Yes. I have H, I have C, I have N. I have 3 types of atom. So it doesn't matter what a geometry is. Every time you have 3 types of atom, it will always be polar because there is no way they can cancel each other out. Now, if it was N here and N here, then it would be linear and non-polar, because linear is a non-polar geometry. But in this case, I have 1, 2, 3 types of atom. That would always get priority, and it's going to be polar no matter what, because 3 atoms cannot cancel each other out. Alright, so far so good. Okay, let's go to the last one. And the last one, we've actually done it, but it's always good to redo some of the problem, especially the harder one. Alright, SO3. How many valence electron does it have? It has, so each one has 6 valence, like it has 28 valence electron. We've done this before, so I'm going to do it a little bit faster. Okay, so S goes in the middle. I have oxygen. I'm going to put this, the other around it. I'm going to put a bond next to the center atom and the surrounding atom. Okay. And then I've already put down 1, 2, 3, 4, 5, 6 electrons already been put down. So I have 24 minus 6 is 18 electrons left to count for. Oxygen has 2, needs 6 more. Oxygen has 2, needs 6 more. Oxygen has 2, needs 6 more. So I want to make sure my surrounding atoms are happy. I want to give them the 6 that they need. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Alright. My surrounding atoms are happy. I have no more electrons left. Then I go to my center atom. 1, 2, 3, 4, 5, 6. Is sulfur happy? No, it's not. 1, 2, 3, 4, 5, 6. How many more does it need to be happy? It needs 2 more to be 8. It needs 2 more to be 8. So I need to make 1 double bond, because my center atom is not happy and I have no more electrons left. My center atom is not happy and I have no more electrons left. So I have to make a double bond. How many double bond? Just 1, because I have 6. I only need 2 more. That's only 1 bond. It doesn't matter which oxygen you take it from. You take it from one of the oxygen. This is a symmetric molecule. You can take it from this oxygen. You can take it from this oxygen. Doesn't matter if you rotate it. They're all pretty much the same. But make 1 double bond for me. So if I do that, I would get S over here. Double bonded. The other ones are single bond still. Okay. Let me make sure I don't lose anything. Is sulfur happy now? Yeah. 1, 2, 3, 4, 5, 6, 7, 8. Okay. What is my geometry? Look at over here. 1, 2, 3 kind of things around it. So 3 things around it. No lone pair on the center atom. It will be trigonal planar. Again, trigonal planar. Don't worry about the double bond. It's not going to affect the shape. It affects the bond length, but not the shape. Is this polar or non-polar? I'm going to come over here. Okay. Trigonoplanar is a non-polar geometry. Trigonoplanar is a non-polar geometry. Is a non-polar geometry. So it's non-polar. So far so good? Okay. Alright, so and that means again they are going to cancel each other out. And just to make sure that you guys are understanding this, I have what's going on is I have a dipole here, dipole here, dipole here. They're going to cancel each other out because what I end up having, I'm going to end up having some electrons here, some electrons here, some electrons here. So electrons are distributed pretty evenly. Each side has a little bit of electrons. Whereas if I go to the last problem, the electrons are not distributed evenly. Nitrogen is more electronegative, hydrogen is not. So almost all the electrons are going to be on this side and no electrons on this side. So you polar when electrons are not distributed evenly. And that's the case. More electrons here, almost nothing here. Polar. Here is non-polar. Electrons are distributed pretty evenly. Okay, and again the shortcut is when you have more than two types, that is nobody can cancel each other out. It's going to be polar and these geometries are going to be polar. Alright, nice job. Okay, we'll start a new chapter next time. Actually, before I let you guys go, let me show you the entire geometry so you don't have to figure it out on your own. So I show you some of the geometry, but this is our full geometry sheet. So again, I want to make sure you understand the concept before I give you the shortcut. Hopefully you understand the concept. I'm going to circle the geometries that are considered non-polar. The ones that I'm circling, these are considered non-polar. These two included. Okay? The one that I circle, those are considered non-polar. And again, that's first thing. Every time you have more than two types, I'm going to write that again because that's really key. More than two types of atoms, that will automatically also be polar. So far so good. Okay, so now if you have more than two types, again there's nobody can cancel each other out. There's three different En value fighting each other. It will always be polar. Now for if you only have two types of atom, these geometry that I circle, those are the geometry that the dipoles will be able to cancel each other out. So again, hopefully you understood the concept, but then this is also the shortcut. Okay, now I'm done. I'll talk to you guys later.